This is Jim Exby with Compliance Professionals this morning. Hey, I'm going to talk to you about electricity today. We've had some people get hurt, some people get shocked. It's no good. Did you know more than 1,000 people a year die because of electrical shocks, and 30,000 people a year are just laid flat on their back and get injured, something terrible. And most of the injuries, their hands and their arms. Terribly bad injuries. And of course, then the rest of your body, depending on a lot of other things, which way the electricity is traveling, and how many volts you're taking or amps you're taking, it's going to make a big difference right there on exactly what happens to you. You can die from an electrical shock. I was reading an article yesterday. A fellow was recharging his cell phone. The little tiny cord, like maybe one of these or so, smaller than this. Yeah, everybody's got them. He plugged it in and the cord was broken. He got a shock from his cell phone, fell over dead. You've got to be careful with electricity and what's going on, and you've got to be aware of your surroundings and electrical current in general to make sure that nobody gets hurt. Remember, use the 5-second rule. Take 5 seconds, look around, make sure you're okay, then proceed ahead. But take electricity in mind all the time while you're working. Okay. Let me talk to you a little bit about electrical injuries being many times more severe than we realize. A lot of times we'll get a shock, like this, and somebody's got a hold of it and they let go real quick and they think, oh, gee, that was horrible. And they sit and rest for 10, 15 minutes, something like that. And then they say, okay, I'm ready to go. You've got to be really careful and monitor an individual, or you have to monitor yourself if you get an electrical shock because of what it can do to your muscles. If you get an electrical shock, the body pushes out all kinds of protein. And let's take an arm, for instance, okay? Bad electrical shock in your arm, you may look at it and say, well, I'm fine. But all of a sudden, your arm starts swelling up. And it will swell up so big, it cuts off all of the blood that's going to the arm. And so the only remedy, I hate to say this, but the only remedy is for the doctor to come in and make a cut from your shoulder down to your wrist or your hand. And the reason they do that is so that all that protein will flow out from your skin and it won't pop the skin open. So please use common sense. If you get an electrical shock, you need to monitor yourself and make sure you're going to be okay. More than 90% of fatalities occur when contact is made with a hot wire or energized equipment housing by a person who is well grounded. Most of these injuries would probably have been prevented if a GFI, ground fault interrupter, had been installed. And I believe the last time I talked to the authorities, there on your job sites you have ground fault interrupters, and that is great news. That's going to help prevent shocks. It's going to help prevent you from getting hurt. So what affects the flow of electricity? Okay, electricity flows more easily through some materials than others. Some substances, such as metals, generally offer very little resistance. So last time I did check on that, you all are around metal quite a bit. Steel makes an excellent conductor of electricity. So does aluminum, so does copper. And I think you could probably name a few other wires and metals that are good conductors of electricity, silver, gold, and so forth, all of them being good conductors of electricity. However, there's a few things around that don't really conduct electricity. That would be glass, plastic, porcelain, clay, pottery, extremely dry wood, and similar substances. They're called insulators. Those are the things that we like to have around us, things that insulate us from getting hurt. Pure water itself is a really poor conductor, but it's really hard to find pure water. The water that you stand in on a job site isn't pure. It's got all kinds of substances in it, salts, all kinds of chemicals that have been on the floor. It's full of it. And when you're standing in water and you're working on something, you've got a piece of electrical equipment in your hands, you're asking for trouble right there. Dry skin, fairly high resistance to electrical current. But, I think it's going to get up to 95 degrees today with 90% humidity or so. I know your skin's not dry. Everybody out there is sweating pretty bad. By the way, make sure you guys drink lots of water, okay? I don't want you falling down on the job site, heat exhaustion, heat stroke, and maybe even getting kidney stones. You never know. Drink lots of water. It's good for you. Let's talk about what causes shock. Sometimes our bodies become part of an electrical current. There's 3 or 4 ways we can get shocked. Number 1, grabbing a hold of both wires of an electrical circuit. You complete the thing, right? Like that. Number 2, one wire of an energized circuit and the ground or the floor that you're standing on. Number 3, a metal part that accidentally becomes energized, for example, due to a break in insulation. Maybe you have an extension cord and you don't realize that somebody cracked it or broke it, and you reach down and grab it. I've seen this happen to somebody. Reach down to pick up the cord, and it was wide open on the other side. Got a horrible electrical shock because of that. And then another conductor that's carrying a current. So when a person receives a shock, electricity flows between parts of the body or through the body to a ground. And where it goes within our body is really important. I mean, if you grab here and you grab here and the current runs through your chest, or if you grab a wire right here and it comes up your arm and it goes down to the floor, it's going through your chest and it's going through your heart and your lungs. And that disturbs the heartbeat that you have. And your heartbeat can go into fibrillation or just plain old stop. Electrical shock can result in anything from a slight tingling sensation to immediate cardiac arrest. So the severity of it depends on the following things: the amount of current flowing through your body, the current's path flowing through your body, the length of time the body remains in the circuit, and the current's frequency. How about static electricity? Does that cause any problems? I'll tell you, about 100 yards away from here, I talked to a guy about static electricity, and he told me a very interesting story. He paints a lot of the steel, and he was having trouble with his paint gun. And so, he looked at it, looked at the tip of it, wiped it down, he tried to paint again. It really wasn't working very good. Went through the same thing, cleaned it up, looked at it, started painting again, and all of a sudden he had a flamethrower on his hands. The paint flowing through that nozzle caused static electricity, and at the end of the nozzle, the paint caught on fire. Static electricity can be a tremendous problem. Now, if you touch a doorknob and you're wearing your socks shuffling around the house, I suppose that's not too big of a deal. But if there was gas fumes nearby, it sure would be a big deal. So you've also got to be careful of static electricity. Static electricity can build up on a pipe because water is running through it. They've done tests for that just to see what's happening, okay? So you've got to keep combustible surfaces away, or combustible products away from static electricity. So let's talk, what's the best way to protect yourself, right, against electrical hazards? Number 1, most electrical accidents result from the following 3 factors. The first one, unsafe equipment or installation is wrong. An unsafe environment or unsafe work practices. Use the 5-second rule. I know this is the second time I've said it. Be aware of what's going on. Make sure you use some insulation between you and that electricity. Something like glass, mica, rubber, plastic, things that are used to coat metals with, so you can be careful. How about the color of wires? Anybody remember? Green is normally the ground, white is the neutral, and the hot wire, black or red. You can't always count on that because, you know, sometimes people wire things wrong. They just do it wrong. So, recognize that electrical shocks result from hazards, inadequate wiring, exposed electrical parts, overhead power lines, running ladders around, defective insulation, improper grounding, overloaded circuits, wet conditions, damaged tools and equipment, and improper PPE. Always make sure the electrical tools are grounded properly or double insulated. Always, you've got to do that. And if the tool isn't double insulated, it's got to have 3-prong plug on it. It's got to have a ground on it. Use heavy-duty grounded extension cords. Don't use cheap extension cords. They're not made for the work that you're doing. They'll get hot and overload. Avoid mixing water and electricity. Don't be standing in electricity and doing things, okay? And don't work on or around a live electrical circuit. Lock out the power so you have control over energizing machinery and equipment. Don't take chances. Okay, let's get to the quiz. Number 1. The best way to disconnect power to a power tool is to pull the cord from the electrical outlet. True or false? Oh, that's false. Don't ever grab the cord and yank it. Grab the plug and unplug it from the outlet. Number 2, you should minimize the use of extension cords. Avoid plugging 2 cords together when possible. That's true, and if OSHA comes by and sees that you've plugged 2 extension cords together to get a job done, that'll be an automatic fine. They'll write you up on that one, guys. Do not plug multi-outlet bars to other multi-outlet bars. Oh, don't ever do that. That'll be a fine. Inspect cords and equipment regularly and report any defects when your shift is over. True. Oh no, that's not true. False. Do it immediately. Take care of it right now. And then number 5, keep extension cords away from heat, oil, and chemicals, sharp edges, and ensure they do not become a job site tripping hazard. True. Please be careful around electricity. We don't want anybody to get hurt, fellas. Take care of yourself and be safe. I'll talk to you next month when we see you again. Thanks a lot. Take care.